Hi, my name is Stevie Bergman. I'm a senior research scientist at DeepMind. This work was done alongside my wonderful co-authors listed here. In this paper, Representation in AI Evaluations, we provided conceptual scaffolding for a deeper understanding of representation for AI systems and AI evaluations in particular. In this short talk, I'm not going to dive deeply into anything in particular, rather outline the main topics. So we might start by asking, what does it mean for an AI system to be representative? But we quickly learn in analyzing this question and maybe even trying to implement something representative or develop guidelines for representation that the question is too unfocused and ill-defined to be useful. Like fairness, representation contains many meanings. It's a suitcase word that packs a lot in. Yet we all use it all the time in everyday speech without the certainty that we're all discussing the same thing. And when it comes to making our systems more representative, we might have difficulties understanding what that even means, or worse, we might feel we know what this means and implement something that is not optimal or beneficial, especially for marginalized, at-risk, or minoritized groups. It's so important we work this out because we still see representativeness called for in news, opinion pieces, literature, guidelines, product aspirations, and proposed policy. We need to pick apart this important concept and understand what kind of representation is good to implement, and perhaps in what conditions or what part of the pipeline or for what goal for AI systems. In a previous paper that dove deeply into socio-technical historical meanings of representation for AI, the authors Chazalo and Levy stated in their FACT 2021 paper that representation cannot stand alone, meaning that it needs to have some adjective to give it real definition. Without understanding the definition for responsible AI creation and deployment, we will not have the guidance necessary to create robust, effective, and responsible technologies. If we instead take this vague question, what does it mean for an AI system to be representative, and break it down by component of the AI development pipeline, say including the data sets that are used to train, evaluate, audit, and/or benchmark models, annotators who label datasets or probe models, stakeholders who evaluate the technology, or even a property of the ML designers themselves, then the question becomes much more manageable. Each of these components has a specific goal. We can consider each stage of development a potential site of exclusion where the meaning of representation needs to be considered. The central question of this work is, how do we think about and practically consider a representative evaluation for AI systems? We primarily focus on evaluation data sets as we develop the concepts, as we sought to be crucial for AI evaluations to be robustly, inclusively representative in order to avoid blind spots in the evaluation of a system and to avoid representational harms from burdening already marginalized groups. It was the most tangible, direct, and high priority place to start. Taking a small step back, why is representation important? We might feel it is, but to pick it apart, we can roughly split representation between why is representation instrumentally valuable and why is it intrinsically valuable. By instrumental, I mean when representation is good because it achieves something. It makes our AI better, surfaces more blind spots or harms in the model, and can lead to a better working system for people. Intrinsic goods are those things we value because they're good in and of themselves. For this, we state the reasons representation is itself is a good quality for a system to have, say because the existence of representation engenders legitimacy, or maybe makes it more trustworthy. Or representation is good in and of itself because if our systems are meant to serve people, then it should be of the people as well. In this work, we more or less assume intrinsic importance and really dive into the instrumentally valuable properties of a representative AI evaluation. Typically talking about evaluation data sets, but the framework could be extensible. And we'll get into this later, but we further contend with the limitations or potential problems with having only considered instrumental representation for system performance as an end in and of itself. To understand and buttress our intuition around current standard practices, we've reviewed a random selection of 20% of accepted papers from NeurIP's 2022 datasets and benchmarking track. The practices for creating benchmark or evaluation datasets include combining multiple datasets, web scraping en masse, and the non-stratified random sampling of a pre-existing population of data. Uniform or random sampling is useful for inference, for example, political polling. However, it is not necessarily the right place for an effective AI evaluation. The right practice for an effective AI evaluation. The concern is that metrics will be dominated by majority groups and may not accurately reflect the model's performance for minority groups. The kind of dominance is very clearly shown in this figure from the paper, Does Object Recognition Work for Everyone? And this image is a distribution of the origin of images in 3 large image datasets circa 2018 versus the world population on the bottom right. You can see that large swaths of the world do not have a significant number of images in ImageNet, COCO, or Open Images, at least at the time when this paper was written. To walk through what better looks like, we consider the questions representative of who and representative of what. In other words, we looked at practices to increase representation by simply sampling by group and how those groups were chosen, then looked at methods to sample by systematically building out coverage of a domain of application. We naturally notice there's this tension between having a less clear or scoped application and being able to define clearly what representation and coverage of the space should look like. We try and bring the reader along as we discuss these methods that lead to more representation by discussing 2 examples. A relatively simple example of a street sign recognition model meant to be deployed in a series of countries, and a Portuguese hate speech recognition model meant to be deployed globally. We ask, what should representation look like in these cases, pulling in good practice from the literature. Then we combine the methods for filling out representation per group and by domain of application into a framework for thinking about good representation in evaluation sets that we call subject domain representation. With this in mind, given that the practitioner identifies the groups or data subjects their system should function well for and has scoped the domain in which the system should be performant, the practitioner's next challenge is to sample for each group such that the group subsets are representative of the events which they are seeking to model. To directly consider the different manners in which a group could express, and to directly consider the different manners in which a group could express in a domain. In some ways, it felt like this conclusion was an obvious one. However, we see it as deeply important to state cogently so that it can be operationalized and advocated for. Or when representation is called for an evaluation or stated as a property of an evaluation, that can then be interrogated. Last, we argue that if you don't directly contend with what groups are represented and in what specific domain, those decisions have still been made and can be inferred based on the evaluation. They just haven't been made deliberately. We then turn to the limitations of representation. For example, when not everything can or should be represented, such as for qualities that exist on a spectrum or are fundamentally fluid. And that full representation, as with full fairness, is likely impossible or totally infeasible in real societally facing situations. In the paper, we discuss the limitations or tensions with representation in data access or existence, foundation models and generalization, representation and surveillance, and representation and power. As many who have dissected representation have found, it's multifaceted and there's much to do. In the paper, we present a further research agenda that includes representation along other sites in the AI pipeline, such as annotation and red teaming. A refocusing of representation towards impacted communities. This is beyond a kind of equal treatment proposed with subject domain representation in this paper towards an equity treatment, where resources are directed towards ensuring representation for those communities who are impacted and historically marginalized. Research that doesn't stop at representative of who being groups and what being domain, and asks representative of when, and what good representation might look like in a data set, say, might change over time. For example, if the manners in which a community uses an application or are impacted by the application of a model changes. And finally, future research is needed to develop best practices to operationalize the subject domain representative framework in this paper. For this, we provide some guidance on thinking it through. Thank you very much. We hope the overview in this talk and conceptual scaffolding on representation in the paper is helpful and engenders future research on this important topic.